I'm going to try to write them in 3 sets instead of 6 of them. The sine of alpha plus beta. I'm going to use alpha and beta. That's A and B in Greek. Alpha and beta. Our book says, you know what? That's equal to sine alpha times cosine beta plus cosine alpha sine beta. I'll leave a space for now. I'll come down here. I'll put the cosine of alpha plus beta. It's cosine alpha, cosine beta, but this is minus, not a plus, minus sine alpha, sine beta. There's the first two in our book. Well, what happens if this sign is minus then? Instead of a plus, the sign. If the sign between alpha and beta was a minus. Is this going to change a lot?
Flip the signs.
Yep. If this is minus, guess what? This will be minus. So when this is plus, that's plus. When this is minus, this is minus. Everything else stays the same. So instead of copying that twice, I go, that's one of them. The cosine, the same thing, but except when it's plus here, what was this sign? Minus. So when this is minus, that sign is going to be what? Positive. Everything else stays the same. So there's 4 of them. Sine alpha plus beta, sine alpha minus beta. Cosine alpha plus beta, cosine alpha minus beta. What about the tangent? Tangent alpha plus beta is equal to tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So when this is positive, notice this is positive and that's negative. This one matches this, this is the opposite. So what happens when this is minus then? This will be minus, and this will be what? Positive. And that's section 20.2. You can do some examples using the sum and difference of 2 angles. Where's my unit circle? Did I throw? There we go. See the unit circle? There's my unit circle. If I said to you, and you'll probably see that on a homework, give me the sine of 15 degrees. And before you pull your calculator out, I'm going to say, I want the exact answer. I want the sine of 15 degrees. I want the exact answer. So if you take your calculator out, it's not going to help you. Because the calculator is going to give me some crazy number. Let me make sure I'm in degree mode. Am I in degree? Nope. Clear. Sine of 15. And that's not an exact answer. That's an approximation. Bless you. They will definitely mark it wrong. This So you go, okay, let me see what you want. So there's my question. Maybe I'll go on the next page because I might need it. I don't know how much space I need. The question is, I need sine 15 degrees. Exact answer. Not approximation. How is that unit circle going to help me? 15 degrees. By the way, what is 45 minus 30?
15.
What's 60 minus 45?
15.
I can use some of these angles, right? I can write the 15 as 60 minus 45 or 45 minus 30. Which way you want it? You choose. What do you want it to be?
Minus.
Which one?
Minus 30.
45 minus 30? Okay. So you want to write the 15 as 45 degrees minus 30 degrees. That's 15 degrees. We have the trig identity we just finished writing that says sine alpha minus beta is equal to what? Sine alpha cosine beta, what? Minus sine of alpha, sine of beta, not alpha. Sine alpha cosine beta minus cosine alpha sine beta. I can say them backward, forward. I'll try to stick with it. Is that what we wrote there a few minutes ago? Try to stick with it. Sine alpha cosine beta, because that's a subtraction, minus cosine alpha sine beta. When it's minus, this is minus. What's my alpha, what's my beta here? 45 is alpha, and beta is 30. So this is going to be what? Sine the 45 degrees cosine 30 degrees minus the cosine of what? 45 sine of 30. Let me grab my unit circle. I need it. And let's see if I can find these answers. 45, that's this one. What is the sine? The sine is the second number. The square root of 2 over 2. Times. What is the cosine of 30? Cosine is the first number. The square root of 3 over 2. Minus the cosine of 45. This is the 45. The cosine is the first number. The sine of 30, which is what? The second number, a half. So what's the square root of 2 times the square root of 3? Square root of 6. What's 2 times 2? 4. Minus, what is the square root of 2 times 1? Square root of 2 over what? 4. I can make it one fraction. So that's what the sine of 15 degrees. Exact answer. Yes?
My calculator can change it. I can just put a sine of 15 and it can change between decimal and math.
I might have to take that away from you during the test.
Yeah.
Should have never told me that. I'll be giving you a cheap one. I'll be giving you a cheap one during the test. which I have them. I done that. I brought boxes of them. I said use these calculators, and the ones I give you are. So you have to say that. Let me see if I can find even some worse than the one I'm going to show you. Maybe there's something here. I know. Maybe I'll give you one like this. That's actually what I use when I give exams. I bring a box of these. See, it says stick property on them. Testing Assessment Center. I bring it back. I say, use these. Like, what? I go, oh, surprise, surprise, use these. So you really want to learn how to do them the correct way, this way. Because I've done that where I brought these to the classes. Okay, hand in your calculator and take one of these. For now. When you're done, I still keep your calculator and let you keep this one. Okay. Let's try another one. Where we might use this. I might say to you, can you simplify? Can you tell me? I'll get him with that. Watch this. Cosine x plus 90 degrees. See if your calculator does that. I decided not to give him numbers.
I don't know if I'd be able to do that.
Good. See that? I got him. So I got to break it down. This is addition. On the board or in the notes we wrote today, what? We have a trig identity that cosine alpha plus beta can be broken down to what? Cosine alpha, cosine beta, minus sine of alpha, sine of beta. What is alpha and what is beta here? Alpha is what? X and beta is what? 90. So it's cosine of x, cosine 90, minus the sine of x, sine 90. Again, grab the unit circle, find the 90 degrees. This is the 90 degrees up there, right? What's the cosine of 90? 0. What's the sine of 90? 1. See them, everyone? Let's use these numbers. The answer to this is 0. Sine of x times the sine of 90, which is 1. From the unit circle, from here. 0 times anything is what? 0. Sine of x times 1, sine of x, so you can rewrite that negative sine of x. Let's try this one. Tangent x minus pi. I want you to simplify this. Again, I need the trig identity for tangent. This is a minus. We have tangent alpha minus beta is what? It's tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Now you gotta work extra hard here. Alpha is what? X here. And beta is what?
Pi.
Pi. So this is gonna be tangent x, not alpha, x, minus tangent what? 90 degrees. Oh, I'm using pi, I'm sorry. Not 90 degrees, pi. I don't know where 90 came from. Oh, I used it in the previous one. Pi over 1 plus tangent x tangent pi. Well, the unit circle doesn't give me tangent. There's the pi. That's the cosine, that's the sine. But it doesn't give me what tangent. So what is tangent pi? Yes. Sine of pi over what? Cosine of pi. Look at pi. What's the sine? 0. What's the cosine? -1. So 0 over -1, which is what? 0. So the tangent of pi is 0. Bless you. Now if you plug it in, that's tangent x minus 0 over 1 plus tangent x times 0. What's tangent x minus 0? Tangent x 1 plus, what's 0 times anything? 0. That's just the tangent x. Over 1, you don't have to write the 1. Get the hang of this? Let me flip them on you now. Just like when you feel good, I'll change them. Notice I was giving it to you in this format and have you breaking it down to this. I'm going to give it to you now in this format, have you combine them back to this and see if you can simplify it. Let's see. If I said cosine, God, my eyes are horrible. Where is it? Cosine, I think it's pi over 5. When I saw it, I even lost the whole problem now. Where'd you go? Okay, I give up on that. I can't find that one. Cosine x, cosine 2x plus sine 2x sine of x. Oh, no, I copied the whole thing wrong. Nope, never mind that. I copied the whole thing wrong. Flip that one, ignore that one. You didn't hear that one. It's on video. But nobody heard that one. I wrote the whole problem wrong. As I said, my eyes are horrible. Let me write it again. Sine of x cosine 2x plus sine of 2x cosine of x. I want to simplify that. I'm going to call this piece here alpha. Call this one beta. Doesn't really matter which one's which. 2x is beta. X is alpha. If I do that, this problem becomes what? Sine alpha cosine beta plus sine beta cosine alpha. It doesn't matter, by the way, which one you write first. So you might write cosine alpha sine beta. But do we have one that looks like this on the board? Look closely. I see cosine, cosine. Yeah, that looks like they just wrote this backward, didn't they? On the board. We have one on the board. It says, oh, that's sine alpha plus beta. They just wrote this one backward. Okay, well, let's simplify it. We know it's a sine function. We know what alpha is. Alpha is what? X. We know what beta is, which is what? 2x. So this problem becomes what? Sine 3x. Put my finger on it. Here we go. How about this one? Simplify. Cosine x plus y cosine x minus y we want to simplify that. Cosine x plus y times cosine x minus y. Okay. Let's see, what's cosine x plus y? That's cosine alpha plus beta, right? What is that on the board? Isn't that cosine x, cosine y, minus what? Sine x, sine y. Times, what's cosine x minus y? Cosine x, cosine y, plus what? Sine x, sine y. Huh? How do you multiply these? I'll give you a little hint. It's a four-letter word, not the one we use a lot outside the class. No. Foil. Yes. Foil method. What's cosine x, cosine y times cosine x, cosine y? Yep, cosine squared x, cosine squared y. Let's multiply this times that. That's a positive, right? Cosine x, cosine y, sine x, sine y. What about this one? That's a negative. Cosine x, cosine y, sine x, sine y. And what's the last one? negative sine x squared sine y squared. Don't these two cancel each other out? So what's left? Cosine squared x cosine squared y minus sine squared x sine squared y. We're not really done with it. That's a tough one. That's a tricky one. Cosine squared x, cosine squared y. My first reaction was, wait, let's break it to cosine squared, cosine xy squared minus sine xy squared and use the difference of two squares. If I did that, I was just thinking about this. That's what I meant to say. Wait, do I have anything common to them? Nothing, right? This is what I was thinking, but I'll be going in a circle if I did that. So I'm stopping here. But if I did that, that's my first reaction was when I said I'm not done. Because if I did that, what will happen? This is a difference of two squares. You can factor it, right? This minus that times this plus that. Well, guess what? If I did that, I go back right here. Right? I'll be like that gerbil in the cage that's going nowhere. Spinning, 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 going nowhere. Yep. The only thing I'm thinking in the back of my head there, maybe I could use like cosine squared equals what? 1 minus sine squared? Would that help? I don't know. When you do these problems, there's no way of knowing if it's going to work or not till you try it. So if I look at this, that doesn't do me any good. But I'm looking at that board, I see cosine squared and sine squared. Maybe I can take the cosine squared, put 1 minus sine squared. Or take the sine squared, put 1 minus cosine squared. Yep. And maybe. I don't know. Let's see. Give it a try at least. So this doesn't get me anywhere, right? This takes me back in a circle. So I'm going to try another attempt to see if I can simplify it more. It looks like I might be done, but you never know. I'm using all my tape on this problem. So let me try one more try, see if I can simplify it even more. So here we are right here. I just write this one down. I'm right here, right? Let me take cosine square y or x, doesn't really matter. But if I take cosine square x or y here, we have one on the board that says this one is equal to what? 1 minus sine squared y. That's what that piece is equal to. I don't know if it will help. Let's see. So this will be cosine squared x times 1 minus sine squared y that's what cosine squared x minus this will be what? What's cosine squared times sine squared? Just cosine squared x, sine squared y. Maybe I can do the same thing here. Maybe. I'm just guessing. Maybe I can take sine squared y here and make that what? 1 minus cosine squared y. So if I put that in, that'll be minus sine squared x times 1 minus cosine squared y. That doesn't look good, huh? Maybe that was as far as I can go with it. I'm just stubborn trying to see maybe something else will cancel. This will be what? Minus sine squared x. Minus times the minus is plus what? Sine squared x cosine squared y. Hey, oh, backward, huh? Those two are backward, don't they? Then I got excited, like, oh, they cancel each other, but they're not. This is cosine square x, and this is cosine square y. This is sine square x, sine square y. So they don't cancel each other out, I guess, unless I made a sign mistake, did I? Minus, that's a plus. No, it looks like what we had before. That was the final piece. I don't see anything after that. Maybe I'm blind now.